And here we go. So chapter 3 is where we're at. We finished up trig functions the other day. We started the chain rule. We're going to work more on the chain rule today. We'll talk about inverse functions tomorrow. Move on to something else called implicit differentiation, exponents and logarithms, and then we take our test at the end of next week. All right, so we got this. Are there any homework questions outstanding from sections past or present?
Oh, I think I might have had one on 3.6. I'm going to check.
Okay. So otherwise, I got a warm-up problem for you all. Let's find the derivative with respect to x of the square root of 2x plus 1. So before, without the chain rule, we couldn't do this, but now we have the chain rule. So a couple of options here. If you treat it as the square root and you remember what the derivative of the square root of x looks like, you could just go that way. So I remember that the square root is 1 over 2 times the square root. It's stuck in my brain. And then I can just plug in the inner function and then multiply by the derivative of the inner function. So cleaning that up, this 2 goes into that 2, right? So I just get 1 over the square root of 2x plus 1. If I look at it the other way, where I consider the square root the 1/2 power, then using the power rule, I get 1/2 parentheses to the negative 1/2. And then I fill in the inner function and multiply by its derivative. Now here we can multiply in any order we want. So I could choose to multiply this thing times that thing there. So 2 times 1/2 is 1. So I end up here with just 2x plus 1 to the negative 1/2 is my answer. Can you see that's equivalent to the blue answer above? Right? Negative exponent means put it in the denominator, and 1/2 power means take the square root. So these are two versions of the same. Which one's better?
Everyone you like.
Whichever one you like, yeah. So simplified sometimes means less ink. The red one looks like it uses a little less ink. Some teachers don't like negative exponents, so they tell you to rewrite without negative exponents, in which case I want something closer to the blue one, but either one I think is fine. All right, ready to try another one? Oh, Sam's got a question?
Oh, wait. Did you want to try another one, or did you want
Sure.
more questions?
I can do a homework question.
Okay, I said 16.
16, okay, so let's look up my version of 16. Oh, that's one of those interesting ones. All right, I'll look up the online version then. 3.6, question number 16. All right, so we've got capital F of x equals f of x, that's a composition. Capital G of x equals the square of capital F. Ooh, another composition. You also know that f of 7 is 10, f of 10 is 3, f prime of 10 is 9, and f prime of 7 is 15. Oh my goodness. We need to find f prime of 7 and then g prime of 7. Okay. Wish us luck here. Screenshot. Initial information. Oops. So this is a puzzle. We can do it though. A little bit bigger. So ultimately we want to know what f prime of 7 is, so that's our goal. Let's see if we can find what f prime of x is. So f prime of x means take the derivative with respect to x, and it's defined to be f of x. So the function is both the outer and the inner function. Okay. So I'll make a note. Outer is f, inner is f of x. So when we put all that together for the derivative, then we're going to get the derivative of the outer function, which is f prime of whatever. And then we plug the inner function back in, which is just f of x. And then we have to multiply by the derivative of the inner function, which is f prime of x. Right. Function composition, outer times the inner derivatives. So then to figure out what f prime of 7 is, we should just be able to plop a 7 in there. So f prime of 7 should be f prime of f of 7 times f prime of 7. So now we're going to figure out if we can evaluate all of that if we were given enough information. All right, so let's see. Do we know what f prime of 7 is?
Yeah.
Or sorry, f of 7. So to think about order of operations, right, we got to start inside here. What's f of 7?
It's 10.
That's 10. Okay, so then, let's see, I'm running out of room. Where are we going to go with this? We'll sneak it up here. So that's going to give me a 10 on the inside. So I need to know what f prime of 10 is, and I still have that sitting next to it. Where are we given that information? Let's see, yeah, f prime of 10 is 9. And f prime of 7 is 15. Yeah, it looks like we were given all the information we needed there. 9 times 15.
135.
What is it?
135.
135, sounds good. All right, so that is my, I should start putting red, f prime of 7. All right, ready for the next part?
No, wait.
Okay, I'll give you a minute. And we'll do another version of that in a minute just for fun, make sure everyone's getting it. Same process as before, except we don't have an equation, we just have numbers to plug in. All right, and I can come back to that if we need to. All right, so let's think about G. We need to figure out what G prime of x is, which means take the derivative of capital F of x squared. So what's the outer function here?
Squared.
Yeah, so that's our outer. And what's our inner? It's capital F, right? And again, we got to be case sensitive. Capital F is different than lowercase f. So switch to red again. So taking the derivative, what's the derivative of a square?
2.
With 2
Yeah, we bring the 2 down, and then we make that to the first power, right? And then whatever goes in there was what was in there before. And what was in there before was capital F of x. All right, and then we need to multiply by the derivative of the inner function, which would be capital F prime of x. And derivative of the outer times the derivative of the inner. The outer function just holds on to whatever it had before, which we did here. So we want to know what g prime of 7 is. So for us, that's going to be twice f of 7. And that's just the first power there, so I can pretty much ignore the first power. That doesn't change anything. Times f prime of 7. Well, we just calculated f prime of 7, right? In the earlier one, we figured that was, what, 135? Is that right?
Yeah. Mm-hmm.
That's 135. Now we just got to figure out what f of 7 is. So let's see. Capital F says take little f and compose it with itself. Okay, so I'm going to squeeze that up here. So that means I want little f of 7. Like that. So going all the way inside, what's little f of 7?
10.
10. So that means we get a 10 in the parentheses, and now f needs to act on that again. F of 10, 3 is 3. So it looks like this guy right here is a 3, and then times 2. Eight, 10? Okay. I was like doing that. Everyone have to do Sudoku. It was very much like the calculus of Sudoku. All right, should we try another one of those? See if we're getting it. We'll come back to it. Oh no, it's fresh in your brains. Let's do another one right now. All right.
I have an awesome question.
Oh, 15 was a good one too. That was the one with the lines. Oh, that's just like it, but other powers. 14 also? That's the one with, ooh. Okay, same thing. Yeah, so this is the same idea with a table. But this one's slightly easier. 13's got the lines. Oh yeah, these are all great. Okay, let's do 15. Let's go backwards. So pretty much attack it the same way we just did it. This one looks slightly easier. And oh, I forgot to get the question. The question is first f prime of a.
Is this going to be on the test?
Oh, sure. This is going to be on the test. All right. Start playing. Mess around. Don't worry about being wrong. That's how we learn. What goes back in f prime here? Little f prime? X to the fifth. Yeah, what it started with goes back in. Okay. I get little f prime of x to the fifth times 5x to the fourth. Derivative of the outer function times the derivative of the inner function.
And then do we just substitute x for a?
And then we just throw an a in there. Yeah. Yeah. So then to do the blue one, I just substitute in. So f prime of a is going to be little f prime of a to the fifth times 5 a to the fourth. And then the question is, can we do anything with that? Let's see.
Well, you know that f prime of a to the fifth is 11.
Yeah, f prime of a to the fifth is 11. So I'm going to get an 11.
And a to the fourth is 3.
A to the fourth is 3. So then I got the 5 in there and then times 3. 165 maybe? Yeah.
We solve for GFX.
And then the next I think we were asked what is G prime. So I'll wait just a moment and do that. Let's see. Yeah, we're going to do G prime of A next. So feel free to get that started. I'm going to bring this into a new screen. Anyone need to look at this a moment longer? Okay. All right, so if you haven't already, try the same thing but for G prime. And then the way I would do it is start off trying to figure out what, oops, what G prime of X is. What's the definition of G here, big G?
X is
Yeah, the fifth power of f of x. So what's the outer function here?
The fifth power.
All right, so we just switched them. So outer is the fifth power, inner is f of x. Chain rule says, black for now, take the derivative of the outer. What's the derivative of a fifth power?
5 times f of x.
Fourth, then f of x goes inside, and that's 1.5. Better. And then I have to multiply that by the derivative of the inner, which the best we can do is say that's f prime of x. And then I just replace those x's with a's. So g prime of a would be 5 parentheses f of a
which is 2.
to the fourth times f prime of a. So yeah, f of a is 2. So that gives me 5 times 2 to the fourth. And f prime of a is 9. So what does that come out to be? 720? Yeah, that sounds good. 720. So we just have to carefully follow our process, identify the outer, identify the inner, put them together, and then see if this information lets us get a number. All right, so the other ones before this are pretty similar. One uses a table and one uses graphs to figure out the missing numbers. Page 14. All right, so here we have a table. We want to find h prime of 2 if h of x is f of g of x. So let's grab the table. So we know that h of x is f of g of x. I got that order correct. Okay. And then we ultimately want to know, our goal is to calculate h prime of 2. So I would start this by just taking the derivative of h, which is f of g of x. So think about outer and inner functions and write down what you think that derivative ought to be. What's the outer function?
F prime.
Yeah, so I'm gonna get an f prime of whatever, and then I have to multiply by the derivative of the inner, which is g prime of, and it happens to have an x. What is f prime accepting here? Yeah, it wants g of x in there. Put that in there. So then to get h prime of 2, I just throw 2's in there and follow the chain of events, see where it leads me. So f prime of g of 2 times g prime of 2. So first we got to find g of 2.
That's 1.
So g of 2 is 1. Yep. So that gives me f prime of 1 times g prime of 2. F prime of 1 is 2. G prime of 2 is 4. So it looks like it should be an 8, according to the table. So the big thing here was just getting used to that idea of outer functions derivative times the inner functions derivative. Different ways to evaluate it. Doesn't look too bad when I do it. Hopefully it doesn't look too bad when you go to do it later or sooner. All right, let's do the graph version. Same idea. We've got a picture of g of x. We got a picture of h of x. Since they're straight line segments, the derivative is pretty easy, right? It's just the slope of each line segment. So we can evaluate function values. Like if somebody said, what's h of 2? I would say it is 3. If somebody says, what's the slope when h is 2, when x is 2? I would just look at this and say the slope appears to be up 2 over 1, positive 2 on this side. What's the slope appear to be on this other side if I had to plug in 4? Be negative 2 on the other side. Yeah, exactly. All right, so your goal, let me get these graphs into my screen. There's one, shrink it down a little bit. And 2. There's the other one. Let's make it a little bigger. All right, so the goal is f is g of h. We want to know what is f prime of 2. All right, go for it. See what you get. First, evaluate the blue thing according to the chain rule, then plug in 2 and see where it leads. Anybody think they got an answer? What do you think?
-4.
-4. Anybody else got a -4 on that? Got a yes, we got a no. Okay, so let's take a peek, see what we got. I'm going to start off, there's a highlighter. I got to figure out that first. What's h of 2? So I look over at h here. H of 2 is 3. Once I get that, I can fill it in. That's a 3. So now I need to go and figure out what g prime of 3 is. And I also need to find h prime of 2. G prime is what? It's the slope. Yeah, so I look at the graph of g here. That's this one. downhill, negative slope, and it looks like that's a point there and that's a point there. So it looks like I'm dropping 2 and running 1. So it looks like the slope is -2 there. And then H at 2 would be this side, and we looked earlier, we thought the slope was 2 there. So it looks like it's -2, because that's the slope at 3 for G, and times +2, which is -4. Yeah. So reminder there that the derivative is a slope function. And these slopes were relatively easy. Again, if this was a parabola, we wouldn't be able to pull this off so easy. That would be if we didn't have the equation. But we could do it with lines. All right, let's jump back into equations. Ms. Miller, wake up, dude. You got this. All right, so let's see. Are there any cute equations in here? Oh, the spring one is cool. We'll come back to that. This one, I think we did one like this last class.
I think we did do this one in class.
We did or did not?
I think we did.
Yeah, I remember looking at this. Because here I have a triple composition. So we have an outer, a middle, and an inner, and it works really nice. You just multiply in order that composition. So if I can identify the outer function, the middle function, and the inner function, then the derivative is just going to be outer prime times middle prime times inner prime. So give that a shot with the primes, not the first powers, and see what you get. I'll put my work up in a sec. I'll take a look at that spring problem. And sometimes with these, I have to think, if I plugged in x, what would I have to do first? Right, that tells me the inner function. After I take the 6th power, what do I do next? The sine gets to act next, so that's going to be the middle. And then the last thing to act is the cosine. And you could leave it 9 cosine or just cosine, either way. I guess I'll call it 9 cosine. Because multiples like that just get carried along. And then I usually leave the outer middle functions blank at first, and then I fill them back in after. All right, derivative of, so the 9's hanging out. Derivative of the cosine is the
Negative.
and I'm going to put that in parentheses to be careful because I'm multiplying by a negative. I don't want to confuse it with subtraction. And then at this point, I could go back and fill in what did this function have to work with before? Sine of 6x. And I go slap that inside. So in here, I got to squeeze a sine of x to the 6th. Then I move on to the middle function. Let's use red for the middle. Derivative of sine is?
Cosine.
Yeah, no problem there. Just cosine of parentheses. And the cosine of the sine had what inside of it? Just the x to the second, so I threw that back in.
6 to the 6th.
X to the 6th. Oop, wrong tool. Find the highlighter though. X to the 6th. And then finally, I can multiply by the inner's derivative.
Which is 6x to the 5th.
6x to the 5th. Excellent. And cleaning this up. I have a whole bunch of things multiplied here. That 6 is a multiple also. Usually we pull the constant multiples up front. So I have a multiple of 9, a multiple of -1, and a multiple of 6. 9 times 6 is what, 54 on a good day? So I would say I got a -54 out front. And there's not much else I can do. I've got a sine of the sine of x to the 6th. Parentheses, parentheses, You guys are getting really good at parentheses and the little boxes online. Yeah, be careful. What else? Times the cosine, parentheses, x to the 6th, close parentheses, and then I pulled the 6 out, so just get an x to the 5th in the end here. And sometimes the computer lets you skip the parentheses on like the square root or the sine or cosine, but that can lead to trouble in some problems. I don't know if anyone's had trouble when they try to blow them off. So just try to use the parentheses all the time when you use a sine or a cosine or a square root. Okay. Not even going to try trig identities on that sucker. All right.
Sounds like fun.
Let's do another one. Let's take a look at the spring problem. New page, spring, that was 12, I believe, yes. A mass attached to a vertical spring has a position function given by twice the sine of 2t, where t is measured in seconds and s is measured in inches. We want to find velocity and acceleration. So this is a combination of using the chain rule and the rates of change stuff we were looking at back in section 4. So we've got this spring, and it's got this mass hanging on it, and someone pulls down on the mass and lets go, or pushes up, and it's going to wobble up and down. Okay. And its height that it wobbles through is given by this s of t is twice the sine of 2t. Accelerate our velocity, let's do that first. That's a v, let's try that again. Is the derivative with respect to time of position. I'm calling position S. So let's see, the 2 in front just hangs out, waiting for the derivative of the sine, which is cosine. The 2t inside chills out for a moment, but what do we have to adjust with?
The chain rule.
The chain rule says you got to take the derivative of 2t, which is another 2. So that tells me, cleaning it up, the velocity is 4 times the cosine of 2t. And so then we can figure out what's the velocity at 3. We just plug in 3. 3 seconds in, the velocity is going to be 4 times the cosine of 2 times 3, or 4 times the cosine of 6. Oh, I don't know if everybody knows this. I've mentioned it maybe once, but not enough. Anytime trigonometric functions are involved in a calculus class, never, ever, 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 ever use degrees. You always have to use radians. Okay? The derivative of sine and cosine depend on radian measure. If we don't have radians, the game changes and weird shit happens. Okay? And I just don't want to go there. It's not that weird. But errors will arise, so you won't get the right answers if you're in degree mode. What's up?
I forgot to change my calculator to radians mode before entering the answer as a decimal.
Yeah, and that'll totally mess it up. Yeah, you gotta be in degree mode. Yeah, radian mode. Sorry, radian mode. Radian mode.
It accepted 4 cosine 6
just as it is,
just as
without
it is.
evaluating it. Okay. Yeah, so I'm just gonna come up with that number just for fun. So 4 times the cosine of 6. And most calculators default to radian mode. And notice Google set up here, just to be clear, oh, you want 6 radians as your input, right? So I would have to do something else to switch to degree mode. So I get about 3.84. Let's go to 5 decimal places just for fun. 3.84068. What does that number mean in this case?
3.84.
Something just a little higher than
5068.
845068?
No,
No,
4
84068. Okay. 84068.
It's almost 4.5. I was like, where did that 5 from?
Yeah. So back to the original problem. We're measuring things in inches per second. So this would be in inches per second. inches per second would be the units of that right there. And let's go see what kind of, so William said it accepts the exact answer and does not ask for the units. Sometimes these problems do. It says, yeah, I can enter a mathematical expression. So I could do 4 times the cosine of 6.
Can't you enter it without the times sign?
You can, yeah.
Do you just prefer to?
I like to write times. Some computer systems, when you enter things into them, if you don't put the time sign, they give you an error message.
Okay.
So it's just a good habit I have. Some are let you be lazy
Replace it with space.
and not type it. Yeah, and here you can replace it with a space and it'll assume you meant times. Yeah, so this system is pretty forgiving. Some systems aren't. Acceleration is the rate of change of velocity, so we need a second derivative. Let's do it.
6.
So acceleration is the rate of change of the velocity. And so 4 chills out. Derivative of the cosine is negative sine. 2t stays there, but we have to adjust, the chain rule says, by multiplying by 2. So that would be the acceleration. So it looks like what, negative 8 sine of 2t?
I'm just confused because I think the 60 makes
Negative 8 sine of 2t here. And we want to know what's the acceleration 3 seconds in. So negative 8 sine of 6, and that's assumed to be radians. Calculator. My Google calculator says it's about 2.235.
2 more spaces. 2 more spaces.
2 more. 2.23532. 23532.
Oh.
So this is the change of velocity, right? So this is a change in velocity per second. What's velocity measured in here? Inches per second. So the units here would be inches per second per second. A lot of people like to write that as per second squared, but I always thought a square second was a bizarre concept. So I prefer that unit. Either way is okay. All right. So, and I probably can enter either one if I enter enough decimal places, but I'm going to enter the exact answer. Sine of 6. And let's see, what was the other one again? That one's about 2 inches per second. Oops, wrong button. This one was 3, almost 4 inches per second. Yeah, so at 3 seconds, do they tell us which direction is up and down? Oops. Here. They don't tell us which is up and down. What would I assume there? It's dangerous to assume things. I guess we can make an assumption. So let's assume here that down is a positive displacement of this thing. So 3 seconds in, it is moving down at about almost 4 inches per second. And it's going to be accelerating. So a little bit past 3 seconds, like 3.01 seconds, it's going to be moving a little faster than 3.84 inches per second is what we would find. Now, eventually, what's going to happen?
Goes back up.
Yeah, the spring is going to resist gravity, and the acceleration is going to have to go negative somewhere not too far after 3 seconds. So, all right, I guess I should submit it since I haven't submitted anything today. Did I tell you the downside of the teacher submit here? Doesn't save anything, yeah.
You don't get any credit for work. How sad is that?
So I usually make myself a pseudo student so I can feel like I'm getting credit for my work. Oh, did I just say that?
Yeah,
Oops.
you did.
Okay, let's do another one.
Peter Parker.
I'm not, no.
Yeah.
I'm not Peter Parker.
Yeah.
Let's see, did we do this one yet?
Yeah, we did.
We did that one. Product and quotient rules. I don't think we did that one. All right, I think we have time for both of these. So let's go back. All right, let's do this sucker. New page. Screenshot. We want G prime. All right, so this is going to involve a great deal of caution. We have to use both the product rule and chain rule. Yeah. So I think I'm going to write this out in stages, just to be safe. So G prime of X, I'm going to take the derivative of the first one. And feel free to jump right to it if you wish. Times the second. Plus the first times the derivative of the second.
You forgot the 23rd power on that.
Nice job. Thank you, Sarah. All right, so I think I'm off to a good start. Derivative of the first function, underlined in a blue highlighter, times the second, plus the first function times the derivative of the second, underlined in yellow highlighter. And then we're going to see if we can clean it up.
We can.
1 second.
So things I am not going to do to clean this up, I am not going to evaluate the 22nd power, or the 23rd power, or the 17th power, or the 16th power,
That sounds like so much.
because that is not worth it in this day and age. But things I can do is, with respect to the sum in the middle, I can say, well, are there things that are common to both sides of the sum, common factors?
Yes.
So let's see. Looking around for common stuff.
There's 8x to the 5th plus 2 is common.
Yeah.
Yeah.
There's some of those here and here.
And
What's the most I can find in common between there and there? 22 of them
2 of them.
are in common. And over here, there's some x to the 4th plus 4 is in common.
Mhm.
is 16.
And there's 16 of them at most in common. The other ones got a little extra.
Mhm.
Okay. 17 isn't common to both. 24 isn't common to both. Now this plus 0, right, that's gone. So I would say I have an x cubed in common. This one has 4 of them. This one has 3 x's. And a multiple of 4.
Mhm.
Oh my gosh, they actually have a lot in common.
So 10.
Crazy. All right, let's see if I can pull all that out carefully. And then the hard part's gonna be figuring out what's left behind. That's gonna be the harder part. Oops, that's not a pen. Again. All right, so I'm gonna start off with the stuff in front. So I have a bunch of 8x to the fifths plus 2's. And I think I have 22 of them that I can pull out.
Mhm.
All right. So those guys are gone. And then I was thinking I could pull out a 4 and an x cubed. So if I pull a 4 out of 10, that's going to leave behind 10.
40.
You mean you pull a 4 out of 40?
4 out of 40, yes, thank you. 4 out of 40, that's going to be 10. And if I pull an x cubed out of x to the 4th, that's going to leave an x behind. I'm taking all of that. Oh, I took some of this too. What did I take out of that?
I'll put 1.
I took all but one of those. Yeah. I'm just going to make little notes as I go. Then we're going to get some x to the 4th plus 4s. 16 of them?
16.
Yeah, so that's going to leave one of those behind there. It's going to take all of those. And that's everything I can take, true?
Yeah.
Okay. Fun part, figuring out what's left.
23 times 17.
Yeah, we got a 23 in the blue stuff.
Oh,
Let's
it's
see,
10x.
these guys are all gone. We get a 10x. Times 10x.
You got an x to the 4th plus 4.
And we have one, yeah, x to the 4th plus 4 there.
And a 17.
Oops, sorry, it didn't come out well. That's in the next part. I'll get to that in just a second. So right now I'm just doing the blue part, what's on one side of the sum. So x to the 4th plus 4, there's one of those. All right, so then I have that plus inside this bracket here. All right, what do we have left over here? We have one of these guys.
Yeah.
So underneath, I'll squeeze that in black. I'll leave it in blue. It's an 8x to the 5th plus 2. We got one of those. Ruby mentioned there's a 17. These guys are gone. Those guys are gone.
That's it.
Oh my. Are we any better off?
Probably not.
Oh, yeah, I guess we're really not much better off. Although we could clean up the inside because that's only a first power. That's only a first power. So that's going to simplify to a single polynomial, but I don't know if we're any better. You got multiple options on how to enter this. Let's see if I can manage one of them in the box. Anybody write this down? Yeah. Okay, so I'm going to pull my screen off to the side, see if I can type this in. Is it worth typing it in? Nah, that's a waste of your time.
That's where we're out of time.
Are we?
Yeah, we are.
Oh, we didn't get to the next problem. Okay, so you never know if something simplifies till you try. If it looks like you're going down a rabbit hole, then just go back to your first answer, plug it in, see if it works. Okay. This one was long. Yeah, this one was wicked long.
Probably rule that's used.